Button. Rational expressions. Okay? Rational expressions means, there's a couple different ways I can say this. Here's how I'm going to define it. A rational expression has an algebraic expression as the numerator and denominator of a fraction. Here's a bit of a trick. Does an algebraic expression have to have an x in it?
Yeah, no.
Usually does, but it can just be a number.
It needs a letter.
Very good. Doesn't actually need, well, that's a good point. It can be letters other than x, but actually can also be just a number. Okay, so this can mean a number or a collection of variables. And what we're going to be working on today is getting these things in simplest form, which sometimes is easy, sometimes is hard. But the first rule is, I'm going to write this the math way, and then I'll try and explain it more in English. Common factors reduce to 1. Now we did some of this earlier. For example, didn't we do something earlier this year? I hope I'm not mixing you up with Algebra 2. Did we do something with, if you have like 25x squared over 5x, for example? Okay. What would this reduce to, Jenny?
I would reduce to 5 over 1, or 5x squared over 1.
Yes, and remember how I said you could write this out as 5 times 5 times x over 5 times x? Nick, does that look familiar?
No.
Jordan, does it look familiar? No, you don't have to write it out like that. There was the whole thing about subtracting exponents. Remember all those times?
Wait, I have a question.
Those are good times. Yes, sir.
Why would you reduce 5 to 5? Why did you do 1?
Well, right now all I'm doing is writing out all the factors.
Oh, okay.
Factors are the big term. Now, here I have a 5 over 5
So it'd be 5.
times 5 over 1, and here I have an x over x times x over 1. Common factors reduce to 1. 1 times something doesn't really matter. So all I'm going to have left is 5 times x over 1, which is just 5x, which is what Jenny was working towards. You guys remember that? Kind of?
Yeah.
Oh,
Okay.
is this the thing where the letters escape from reason?
No, that's under the radical. That's under the radical sign. That's different. This is the one where I gave the rules about subtracting the exponents. Now the problem is, with these algebraic expressions now in the fraction, we can have more than one operation. What's the only thing going on? Look at this one here. This middle expression. What is the only operation happening in the numerator or the denominator? Jenny?
Multiplication.
Jenny, your voice changed. With that, I'm going to start calling him Jenny for the rest of the year. Multiplication on top, multiplication on the bottom. Here's where this gets fun. Now we can mix and match, put some addition or subtraction up here.
But doesn't need any, does it?
That's a great phrasing of a question, actually. Doesn't need any. This one doesn't need any, but sometimes there are situations in life that are described that way. And the problem is, this is another one of those cases where this is the baby step math. We're not going to get to any word problems of how you use this. That doesn't happen until like Algebra 2. Sometimes pre-calculus. But if I have 2x plus 6 over 2, okay? Here's the problem. For tonight, all I want to talk about is getting this in simplest form. Okay? Now, normally, if I just had the 2x and the 2, what would you do?
You just take away the 2
times
so it'd be x plus 6.
Take away the 2's, yeah. Let's pretend the 6 isn't there at all. So I would take away the 2's and then it would just be x, right? What if I just had the 6 over 2?
It would be 3.
Divided by 2 and it would be 3. Okay, that would be wonderful. I can do this a couple of different ways from here. First rule. If you have addition in the numerator, okay, if you have addition in the numerator, you can make this into multiple fractions over the same denominator. If you have addition or subtraction in the numerator, you can change this into multiple fractions and they'll have the same denominator. 2x over 2, you guys just told me was x. 6 over 2, you guys just said was 3. really think for this. If I had just crossed out the 2 and the 2, Jenny said that would have gotten x plus 6. Would that be this answer?
Yeah. Well, yeah, it'd be that,
Well-
but reduce.
Well, now
You
it'd be...
did half the step, but you still, because you reduced
Right.
one of it, you still have to reduce the other.
Correct, so that would be incorrect. Just crossing out these 2's and getting x plus 6 would be incorrect. If I had just done the 6 and the 2, that would have left me with 2x plus 3. That also would have been incorrect. Alright, but this isn't, so you have to take the 2 and divide both of them. Yes?
This might be moving ahead a little bit, but what if you have, like an equation on the bottom, so it was like...
Addition and subtraction on the bottom? Can't do that. So you can't split it up. I'll get to that in 1 second, okay? There's another way to picture this, and I want you guys to have the option to look at this a couple different ways. What's the common factor between 2x and 6? Greatest common factor.
12. No.
That's the least common multiple, okay?
Wait, what?
The biggest factor, the biggest
Oh,
factor
2,
contained in 2. So what I can do is I can rewrite the top as 2 times x plus 3. Remember that factoring we've been doing?
Yeah.
Yeah.
Okay, if you find the greatest common factor, pull it out, and then you ask yourself, 2 times what equals 2x, 2 times what equals 6? That sound familiar?
Why would you do that, though, if you already knew that?
Ha ha ha, I'm glad you asked. Because common factors reduce to 1. And now you see here, the 2 is a coefficient. And here the 2 is buried into the 6. But once I have the 2 outside of the parentheses, now I can reduce it. 2 divided by 2 is 1, and be left with the x plus 3. If I can get a single factor with no addition or subtraction outside of the parentheses, I can cross it out and get to my answer. Either of these methods works just as well when there's addition or subtraction on the top. Jenny, getting to your question, only one of these methods will work if the addition or subtraction is on the bottom.
But why would you do that if you already knew to cross it out and the answer?
To just cross it out from both?
Yeah.
Okay, because this will work whether it's in the denominator or numerator, and this won't. So this will always work. And when you're crossing out the 2 with both, this is what you're really doing, whether you picture it that way or not.
Can you do an example where it's denominator or
Yes, I'll do that in a moment. Let me answer Brandon's question first. Yes,
So
sir.
basically, you're just doing like, or crossing out the ones that are the same.
Crossing out the ones that are the same, but there's a trick to it. If you have addition or subtraction, you can't just cross out these 2 even though they're the same.
But
You
why
have
are
to
you
take
crossing them out?
Because the directions will be something like simplified, get to simplest form. Okay? And it's not the simplest form if there's anything, if you can find a common factor, you have to cross it out to simplify.
Okay.
Alright? Just got to. Now, oh well, there's the water bottle. Now, the other part to this, though, is, Brandon, you can't just cross out this 2 and this 2. You have to either break it up into 2 fractions or pull the 2 out of everything first.
But is there going to be like a formula for that?
No, we're not doing cross multiplying. That's solving
But there's no
proportions.
formula for this?
Nope. You got to understand that. You got to understand the properties of factors. You got to know what's going on. I'm doing another example. There are patterns to it, though. So now let me do an example of what Jenny was asking about. Dina, these are the lessons I wish Stephen hadn't slept through. But it happens with a lot of people.
I'm gonna watch this video.
You know what, I think I will. Okay, now, let me make sure I get this. I'll start out with a very simple one. Okay, 3 over 3a plus 9. Most common mistake in the world. I still have a couple kids doing this in honors pre-calculus. Most common mistake in the world is to cross out this 3 and this 3 and call it a day. Cannot do it. Yes, what do you think I do?
You have to divide by both the 3 and the 9, so it's going to be a plus 3.
Okay, the 3 will be on the outside, though. And what's left will be a plus 3. Is this what you were visualizing?
Yeah.
Okay, good. You're not really dividing when you do this. You're actually factoring. There's a slight difference between the two.
But couldn't you just stop at what I said? Like, not even just know that you divide, or factor 3 into 3 and 3 into 9?
As long as you're careful, yes. But I want you to understand that this is what it's actually doing. Okay? Now, what is 3 divided by 3? Everyone agree?